Now, the very last part of lesson 2.4 is about the substitution method for solving a system of linear equations. So the idea behind substitution is that we have at least one equation which is solved for either y or x. Generally speaking, it's solved for y because that's slope-intercept form. So think one equation is kind of like a slope-intercept form. The other may or may not be. So the idea is that we're going to substitute out for this variable y the expression x plus 1. So where do we substitute it in? Well, we substitute it into that first equation. So we take the variable y from the first equation and we replace it with the x plus 1. And then that first equation has a single variable to solve for. So you can see that in example 1. Instead of doing 4x plus 2y equals 14, we replace the y with the x plus 1. So we get 4x plus 2 times the quantity x plus 1 equals 14. This is an equation in one variable, so we can solve it using the, general solving equations method, and you come up with x equals 2. You plug in that 2 for the x value in one of the equations. It's generally easier to plug it in for the slope-intercept form equation, and then solve for y. Okay, but the whole thing depends on replacing this letter y with the expression x plus 1. And we replace it with that because we have y equaling x plus 1 in that second equation. The one thing I see people mistake on this is they forget to put parentheses around the entirety of x plus 1. So they'll put 2 times x and then plus 1. Make sure you put parentheses around the whole thing so that your first step is to distribute 2 times x, 2 times 1. So let's look at a problem here. Let's do the cooperative group problems. Let's look at problem number 1. It says solve the following systems of linear equations using substitution. So x minus 2y equals 4 and y equals x minus 6. So what we do is we say, well, this one is already in slope-intercept form. So let me take and highlight this x plus 6, or x minus 6, excuse me. And we're going to replace the letter y in the first equation with x minus 6. So if we do that, we end up with x minus 2 times the quantity x minus 6 is equal to 4. Now that is a single variable equation. We can solve that. The way we solve that is distribute this minus 2. Minus 2 times x is minus 2x. Minus 2 times negative 6 is a positive 12 equals 4. Combine like terms, we get minus 1x plus 12 equals 4. Subtract 12 from both sides, you get minus 1x is equal to negative 8. Then divide both sides by negative 1, you get x equals 8. Now, once we have x equals 8, just like we did with elimination, we plug it back into one of these original equations. I generally like to plug it into this one, makes it a little bit easier because we've already solved for y. So y equals, 8 minus 6, y equals 2. So the solution to this problem is the point 8, 2. So there you go. That's the idea of substitution. Let's do one more problem just so that we hammer down the point. Let's go to the second cooperative group problem in 2,4-D. Y equals 3x plus 6, y plus 2x equals 11. We're trying to find the solution to that system of linear equations. Now notice the first one is in slope-intercept form. The second equation is not. So I'm going to utilize this first one when I do my substitution. In other words, I'm going to replace the y with a 3x plus 6. So again, in our problem number 1, we saw that slope-intercept form was in the second equation. This one we see slope-intercept form is in the first equation. So here we go. We take this 3x plus 6, which I'm highlighting there, and I'm going to replace this letter y. Whoops. Let's undo that. So replace this y here with the 3x plus 6. I won't even highlight it. So I always put my replacement in parentheses. In this case, it's not so important because we have a coefficient of 1 in that second equation, but we take the y plus 2x equals 11, and we make it 3x plus 6 plus 2x equals 11. Now I can combine like terms. I could distribute. If I had a coefficient of y, I would distribute. But since I have no coefficient, it works just like we didn't have parentheses there. So combine like terms, we end up with 5x plus 6 equaling 11. If you subtract 6 from both sides, you end up with 5x equals 5, which means dividing by 5 on both sides, x equals 1. If x equals 1, then we go into our original equation, y equals 3x plus 6, and we replace the x with the number 1, and we see that y has to be equal to 9. So therefore, the solution is the 0.19. And there you go. So that's how we deal with substitution. Obviously, the word substitution gets its name from the fact that we're substituting this expression, this 3x plus 6 in this case, in for one of the letters. So we're substituting out this letter and putting in the expression 3x plus 6. So there you go. That's how to do substitution. And now we are done with chapter 2.